Hello everybody, today we are here to talk about square roots in the Pythagorean Theorem. So, you already know how to find the square of a number. The square of 4, written 4 to the second power, is equal to 4 times 4, which is 16. Okay, so piece of cake. The square root is the opposite of squaring something. So, the square root of 16, written like this, the square root of 16 is 4. Okay, so here's a problem with square roots. There's actually two numbers that are squared that equal 16, 4 and negative 4. This is true for all positive numbers except 0. Well, 0 is not a positive number, so all positive numbers. So 4 times 4 is 16, negative 4 times negative 4 is 16, okay? 3 times 3 is 9, negative 3 times negative 3 is 9. Okay, so we got to have some rules on how we do this. So if we square root 16, we are going to say that the answer is 4. But if you take the negative square root of 16, you're going to say that the answer is negative 4. And we can also write this. We can put a plus or minus out here, and then you'd have plus or minus. However, if we have an equation, this is just an expression, the square root of 16, the negative square root of 16. If you actually have an equation like this, x squared is 16, you need to put both the answers down. So since there's two numbers that when I square them, I get 16, there's two answers. X is plus or minus 4. Okay? All right, so right here, find the square roots of these numbers. So this is going to be, the square root of 81 is going to be 9. The negative square root of 81 is going to be negative 9. The square root of 0 is 0. All right, the square root of 4/9. Well, when we have a square root of a fraction like this means we square root the top and we square root the bottom. So this is going to be 2/3. Okay, what about this thing? Well, there's no number that I can square and get negative 4. If I take 2 and I square it, I get 4. If I take negative 2 and I square it, I get 4. So what happens here? Well, if you square root a negative number for right now, we're just going to write no real solution. Okay, now I don't want you to write no solution because there is a solution. There's two solutions to that. But since we haven't talked about imaginary numbers yet, we don't know the answer to that. So we're just going to say no real solution. There's no real number that I can do this with. Okay, next one. Plus or minus the square root of 121. Well, that would be the square root of 121 is 11, so this is going to be plus or minus 11. The square root of 0.09 is going to be 0.3, because 0.3 times 0.3 is 0.09. Now, the square root of 7, okay, this is an interesting one. So if I want the exact answer, I just have to write square root of 7. Okay, if I want a decimal approximation, all these are exact answers except this one, because 7 is not a perfect square. So I can't square root it and get a nice answer. I can square root it. The square root of 7 is about 2.646. Whoops, 0.646. Okay. If I want the exact answer, I need to write down square root of 7. If I want a decimal approximation, I'm going to write down 2.646. Okay? So there you go. All right, evaluate the following square root when a equals 1, b equals negative 2, and c equals 3. And I want the square root of b squared minus 4ac. All right, so here's what I'm going to do. I'm going to take these numbers, I'm going to sub them in here. So I'm going to have the square root. B is negative 2. Make sure you put that in parentheses because I'm squaring negative 2. I want negative 2 times negative 2. Remember, this is not the same thing as this. This right here is positive 4. It's negative 2 times negative 2. In fact, let's write that down here. Okay, this is negative 2 times negative 2, which is positive 4. Okay, this is negative 2 times 2, which is negative 4. So make sure you get those parentheses around there. Okay, minus 4. A is 1, and C is negative 3. Okay, so here's my equation, or here's my expression. So now I'm going to go ahead and I'm going to solve this thing. Okay, so negative 2 squared, I do everything under the square roots first, okay? Square root is a grouping symbol. So I do all this first. So this is 4 minus, now this is 4 times 1 is 4 times negative 3 is negative 12. Okay, now remember that when I minus a negative, that's plus a positive. So this ends up being the square root of 16, which is 4. Okay, so there we go. Okay, evaluate this expression. 1 plus or minus 2 square roots of 3 over 4. Okay, a couple things here. There is 2 answers to this. Okay, the first answer is going to be 1 plus 2 square root of 3 over 4. And the next one is going to be 1 minus 2 square root of 3 over 4. Now remember, a division bar like this is a grouping symbol. I do everything on the top first, everything on the bottom second, and then I divide. Okay? So over here, I can simplify this a little bit. I could change this if I wanted to 1/4 plus 2 divided by 4 is 1/2 square root of 3. So I just put the square root of 3 up here like that. I could do that. I don't really need to do that. I'm going to get a decimal answer for this. Okay. So here's what I'm going to do is I'm going to do 1 plus 2 times the square root of 3. And that's going to be 4.464 approximately over 4. And then I'm going to go ahead and divide that by 4, and I'm going to get approximately equal to 1.116. Okay, so this would be the exact answer right here. Either one of these, you can have either one of those be the answer. This is a decimal approximation. Okay, now over here, this, I'm going to do the 1 minus 2 square root of 3. This is going to be negative 2.464 over 4. So then I would divide that by 4, and I would get negative 0.616. Okay, so again, this is that's equal to this, and this is approximately equal. So I have my 2 answers, one here and one over here. Okay, the Pythagorean Theorem. So the squares of the sum of the legs of a right triangle is equal to the square of the sum, or of the hypotenuse. Okay, so here's the thing. The first thing you need to be able to do is identify the sides of a right triangle. Always identify the hypotenuse first. So that's the side that's always across from the 90-degree angle. So here's my hypotenuse. Okay, that means that this is a leg and this is a leg. The 2 legs meet at the 90-degree angle. Now, we call one of them leg 1 and the other one leg 2, and it doesn't matter which one's which. Okay, I prefer, if you're going to write the Pythagorean Theorem, that you write it like this. Leg 1 squared plus leg 2 squared equals the hypotenuse squared. Okay, the reason that I like that versus this, a squared plus b squared equals c squared, is this is true when a and b are the legs and c is the hypotenuse. But it's really easy. I can mess people up by just switching the a out here to the c, and then it's no longer a squared plus b squared equals c squared. It's c squared plus b squared equals a squared. People don't make that mistake when they write it like this. Okay? So the sum of the squares of the legs is equal to the square of the hypotenuse. Okay, so find the length of the hypotenuse in the triangle here. All right, so the first thing I'm going to do is I'm going to get my first leg is going to be 5 squared plus the other leg is 12 squared. That equals the hypotenuse, which is h squared. Okay, so this is 25. Everybody knows this is 144. Okay, I usually like to have my variable on the left side. So h squared is 169. Now, don't forget, I need to square root both sides of this. So h is going to be the square root of 169, which happens to be 13. Now, so I know this is 13. When these three numbers are all nice whole numbers, that's called a Pythagorean triple. So 5, 12, and 13 is a Pythagorean triple. Okay. If I have a Pythagorean triple, I know the sides of a triangle are Pythagorean triple. That tells me also that I know that that angle has to be 90 degrees. Okay. What about this one? Oh, now I already know the hypotenuse is 15. Okay, so on this one, the leg x is squared plus the other leg 12 is squared, and that equals the hypotenuse squared. So 12 squared is 144. 15 squared, everybody knows, is 225. So I go ahead and I subtract 144 from both sides, and I get x squared is 81. And now I'm going to square root both sides, and I'm going to get x is 9. Now, this was an equation. The answer is plus or minus 9. However, since this is the side of something, it's a distance, I get to throw the negative answer out because distance can't be negative. Okay, so it has an extraneous answer of negative 9. I just want the positive 9 answer. Okay, a baseball diamond is a square with sides of 90 feet. What is the distance from home plate to second base? So here's my baseball field. Here's home, first, second, third base. Okay, the distance from home plate to second base is what I'm going to calculate. I know that this is 90 feet, and since it's a square, that tells me also that this must be 90 feet. So now I can use the Pythagorean theorem that says 90 squared plus 90 squared is equal to the hypotenuse, which is d squared. So this is going to be 8100. This is also going to be 8100. So d squared is going to be 16,200. Okay. Now, depending on whether I want the exact answer or a decimal answer is depending on what I'm going to do here. Okay. So this is the distance. I really want to know the distance. I'm going to go for the approximate answer because it's going to make more sense to people. So I'm going to square root 16,200. Okay, so square root 16,200 comes out to be approximately 127.28 feet. Okay. Now, a lot of people think that a baseball diamond, since it says diamond, is an actual, they think it's a rhombus, they think it's a diamond shape. Okay. It's not, it's a square. Okay. A square is a diamond, a square is a rhombus, but it's a nice perfect square. Okay. Whoops. I don't have your assignment on here. I'll get the assignment added to this. Yeah, I don't have the assignment on it, but I'll get it added to this, and I will see you guys in class. Have a great day.